Hello everyone, let's check out for one more example of viterbisde decoding. Earlier case we have seen how to prepare the trellis diagram, how to track the path for the trellis diagram with the help of this kind of thing, that is tracing of the path based on the input bits. Now we will just see one more example of viterbisde decoding algorithm for let's say the errorless system. Means if we assume that whatever the encoded out, if the same is received at the decoder, we expect that system should have been called as an errorless system. But how to track it? Let's proceed with this example which we started with. This is the example where we can observe that input bit 1 will be accepted every time. So it will be A is having the value 1 and two output bits will be there. So X and Y. So it will be n equal to 2. It's 1 by 2. And constant length for this one will be CBA. Total 3 shifts will be there. So that's why we can say it is 3. So 1 by 2 comma 3, that is what the convolutional encoder given to us. So in the earlier case we have seen how to prepare this state table. I have also mentioned the simplified method to prepare this state table which is quite effective to go for. So once we prepare the state table, unfolded sequence of the state table, that is nothing but the trellis diagram. So we can unfold it to get this particular thing, that is trellis diagram. Once the trellis diagram is obtained, then we can go for plotting a path. So this is what the thing which we have seen in the earlier case. Say if the input sequence is 100 111 011, we are getting the path like this. By following it, obviously 1 means it is a discontinuous, then continuous, continuous, discontinuous, 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 continuous, discontinuous, discontinuous. Like this, by following the path, we are getting this as an output. That is what encoded output. Now let's assume that the same output, once it reaches to the receiver end, let's say it is a noiseless system or the errorless system. If it reaches exactly the viterbisde decoding algorithm will do, how it will track for the same path, how the survival path will be tracked, we will see. So for looking at that, since it is 1 by 2, if the continuous stream is given, I need to track 2 bits at a time and put it at the respective distance. So this is what provided. So seen that this is what the encoded output, we will go for the viterbisde decoding. So since it is errorless, but how to justify it is errorless? So for that one, we will go for this. Let's say this is what the states written over here. Earlier also I told you that 0 1 1 0 this can be shuffled. The thing is accordingly you need to modify this list. So for this, when we started with the 0, metric value for the 0 0 earlier, it has to be assumed as a 0. So when it is compared with 1 1 1 value over here after splitting the entire bit stream 2 bits. Why it is 2? Because output will be in 2 bits. That's why it has to be treated like this. So for the first instant 0 0 1 1 it will be 2. After comparing, it will be giving the Hamming distance as a 2. So 0 plus 2 it will be over here. Now the next thing, let's compare it with the input bit 1. So when the input bit is 1, for the 0 0 next state will be 1 0. So 1 1 1 1 it will giving the comparison as a 0. So 0 plus this earlier metric value 0 it will give the 0. So at this point it is quite clear. If I track it this particular path further, either it will retain the value as a 2 or it will increment plus 1 or plus 2. It means here itself we can decide that this particular path has to be discarded. Means this second path also we can discard. Means either it will be 2 plus 1 or 2 plus 2, rest of the thing. So at this point we are able to just justify that we are going for only this path. Means path tracked from the, let's say, analysis of 1 0 further. So 1 0 will be further tracked. So here it will be tracked like 1 0, we have the next state as a 0 1. So that's why output will be 1 0. So 0 plus comparison 0, output will be 0 here. Next is for input bit 1, 0, 0 1, 1 0 means 0 plus 2. So this path has to be discarded since it is giving the output over here as a. So let's follow this particular thing. So it is quite clear that we tracked it like this. So this is what the tracked path, 0, then 0, then 0. This is what track. So when we analyze it for the state 0 1, since we are at this particular point 0 1, next state will be 0 0 for the input bit. Obviously it is 0, so output bits will be 1 1. So this 1 1 will be compared with this 1 1. So 0 plus 0. So this is what the bit. So here the two bits are written. These are indicating that first 5 is due to this particular path. We are discarding it, so no need to analyze. So for simplicity, just follow least metric value path. Once we reach at this point, so this 0 is obtained, but what about the input bit 1? So at this stage 0 1, the input bit is 1, it is showing the output bits as a 0 0, and the path will be directed from 0 1 to 1 0. 0 0 and 1 1, once they are compared, it is showing that metric value or Hamming distance over here, it is 2. So 0 plus 2, it will be 2. That's why this path has to be discarded. So the same kind of scenario will be followed till the last. Once we follow this least metric value path, that is 0, here also 0 0 0 0, then 0 0 0 0. Once we follow the least metric value path, at last we'll get this kind of convention. Okay, so this is giving the idea that by following the path it is 1 1. So that is what 1 1 1 0. So since there is no change in the path followed after applying the viterbised decoding algorithm, that's why we can say it is the errorless system. And it will give the input bit stream, means the original message which is same which we started with. So 1 0 double 0 double 1 0 double 1. So it is over here. The same message will be obtained. So that is all about the viterbised decoding algorithm and how it is quite effective to analyze for the errorless system also. Thank you everyone.